Digital twins, it's on everyone's lips at the moment. Before we go into digital twins, I want to speak about your mindset. Mindset is most probably one of the biggest challenges that we have when it comes to change in our environment. And I've got a mentor that teaches me that says, you've got one of two choices. You're either going to be part of the problem or you're going to be part of the solution. That is a mindset change that you have to make before you enter into digital twins. It's a mindset change that you have to get your team to make and understand that where we are going or why we are going in this venture, and we need to make sure that our mindsets are correct. We all know there's a certain amount of real estate available. Real estate is not going to increase. There's a certain amount that's available and we have to work with it. Real estate, why is that important? Because we need to start designing smarter. We need to start designing with more intention. Okay? What helps us with our design is data. Data is crucial to where we are going with digital twins. Because what you put in is what you're going to get out. If you put some rubbish data in, you're going to get a rubbish result. I always tell people that you can't expect me to build a castle if you're giving me poo. I'm going to build a hut. It's not going to be a castle, it's going to be a hut. So the case for digital twins bridge the physical and the virtual worlds. And that's what it is. Everyone asks the question, what happens to a rivet model when we are done constructing? What happens to that model? It gets given to the client and it's shelved. As consultants, we know that we put a lot of work and effort into it. Architects put a lot of effort and work into their models. And now we are done. Hand it over, USB file, put in a drawer, gone forever. Not anymore. What is a digital twin? We have to ask the question, what is a digital twin? Very simple. Let's first start off by what's the difference between BIM and your digital twin. And I want to read this to you because it's so profound for me. It says, BIM is the blueprint that builds the hospital, the building, whatever you're building. So BIM is the blueprint of your facility, of your building. The digital twin is the living dashboard that runs it. Many organisms starts with BIM and later enrich it into a digital twin by layering on real-time data and analytics into that model. So BIM is our rivet model, our CADs, our PDFs, that whole process of going to construction. Digital twin is taking it a step further. We're taking it into an environment where it is becoming a live model. It's becoming a live organism, and we can track and see and get data. It's so important that we look at this data because this data is going to help us to understand where we are going and what we need to do and how we need to change. I worked for an electrical engineer, and he said to me, he did a residential area, and they had some data, some very interesting data that they used. And I said to him, okay, please explain to me. He says to me, you're a bit young, but I don't know, do you know the story Dallas? And I said to him, yeah, I can remember my grand watched Dallas. He says Dallas was a key in the design of his whole electrical infrastructure. And I said, how was a TV show a key in this man's design? And he said to me, you know, Dallas started 7 and it ended at 7:30. And he said at 7:30 something happened. I said, what happened? He said to me, at 7:30, everyone stood up from the couch and they put on the kettle. He says, the peak and the spike in the power that was required in that time was phenomenal. And he said that was the standard that he used so that he can design this residential areas power requirements. So data is crucial, but not just any data, real life data. Data that we can trust, data that we can use, data that has a validity to it. A BIM model is a live operational data. It gives back the live operational data. So what we do is you take your rivet model and you connect it to your building. Continuously updated real life information. So it's becoming more easier to get a building and sensor up a building. Getting equipment to talk to a system. Getting sensors in your light fittings. Getting sensors in your mechanical equipment. We see a lot of it happening in the data center industry, where everything has to be managed and monitored constantly. And what is the beautiful thing about that is, we've got the rivet model already, we've got the BIM model already. Now what we are doing is, we are plugging the two into each other, and we are expanding the life cycle of our model. So now it just doesn't end with construction and over, but this thing starts becoming live data into our hands. Used for monitoring, analyzing, and simulating and optimizing. So what that means is, we take that model, we take the information that we have, we know it's real-time data and real-time information that we are receiving from that building. And as a developer, the developer can come to the construction team, it can come to the engineering team and say, listen here, I've got this building, this is the data that's coming out of this building. This is the new building that we are going to do. How are we going to optimize this building to be much better than the previous version that we have built? We've got real life data, data that we can trust. It's not something that happened in the 80s. It's not something that was done or we read in a textbook. The same engineer taught me the following. When we started in the 80s and 90s, I don't know if the people can remember the fluorescent light fitting. We used to have a 1200 by 600 2 by 28 watt. And that thing was the normal light fitting that we put into offices. Wherever we go, we would put those light fitting in. And he's always said to me, Jacques, you need to make sure that you design, if the SANS says 300 lux, you need to make sure that you design to 350. And I said to him, but SANS only requires us to do 300. Why are we going to 350? He says, just trust me. I did the design for him and he checked it. And he said to me, how many light fittings is it extra? I said, it's about 1 fitting per room. And he said to me, that's fine. I said to him, okay, but you need to explain to me, why are we doing this? And he said to me, over time, that light fitting will degrade. And he says, in 3 years' time, if we design to 300 lux, we're going to sit with a problem. He says, because now that light fitting has degraded, and we're under the SANS regulation. He says, but now we're costing the client more money because they have to take out all of those fittings and replace them. He says, but if we do it to a 350 lux standard, he says, in the next 5 years, when it degrades, it's going to be at around about 300, and we're still going to be in the ballpark figure. He says, so we're actually saving the client money. You see, and that's what you need to do and what you want to do. Because we need to look at the longevity of our buildings. We need to make sure that in the next 5 years and 10 years, that this building can still function to what we have designed it to. Because the cost of running and replacing and repairing is getting more and more expensive by the day. So we need to make sure that there's a way to optimize our design so that we can assist our client. Why digital twins matter in the engineering workflow? It improves designs through feedback loops. The information that we are constantly receiving back from the building, from the sensors, from all this live organism, if you can call it that, is giving us information. And it's information that we can trust because it's real live information. It's information that we can look at and use to refine our engineering. Engineering refined future projects based on real performance. We can actually monitor how things are performing. Because if you specify anything in a building, you are going to a specification of whoever is giving you that product. So you're looking at that and you are making an assumption. But now we're getting to a space where there's going to be feedback of over the next 3 to 5 years from any piece of equipment, and we can see if that equipment is actually doing what it's supposed to do according to that document. Because we've got the live data that we can trust. Assumptions get replaced with measurable insight. Now we can go to the client with confidence saying, here's the data. The data is backing you as a consultant. So you don't have to put your head on a chopping block and say, we think this is going to work. No, this is going to work. Not because you say so, but because the data says so. And that makes what we are doing a lot more trustworthy, and we've got the confidence that what we are doing or implementing in our clients' buildings is going to work because there is proof of it. Better coordination across disciplines. A shared digital twin becomes a single source of truth. Like the architect said, we've got a single source of truth. Everyone's working on the same model. Everything gets detailed in the same model. Everyone's understanding how this building is going to operate. Everyone's understanding how this system is going to work. They visually can see how everything fits into place. So it helps us, if we start off with a mindset that we are going to do a digital twin, it gives us the mindset that when we are busy designing, that we look at all the finer details. We make sure that we put the right generator set into the room. Why is that important? Because there's a lot that goes on in a generator room, for example. And it's like that with there's a lot of services that's being installed in there. And if every service details to what the design or what the construction is going to look like, firstly, the client sees what he's getting. Secondly, it allows us to do design and not do clash detection. So we are avoiding clashes by seeing the real information, the real data in the project. So that helps us a lot with better coordination. Structural, electrical, and mechanical teams work on aligned data, all sharing the same central model, all working in the same model, all seeing the live data that's being presented. And we can make educated decisions according to what we see in the model. We don't have to guess, we don't have to phone and say, listen here, what system are you using? How big is the panel? What is required for this panel? All the information should be in the model. It reduces clashes and rework. Because now we are designing more smarter. We are designing around each other. We are designing with what I'm seeing, I can trust and I can design around it. Or I can use the information that's in the model to make my design work and be more efficient. It improves communication between office and the site team. This is crucial because there is a lot of times that's where it's missed. Because what happens at site? At site, they receive PDFs, they receive a 2D drawing. But by using like an ACC structure, we are able to share that model with the contractor and not necessarily use it to build off, but to get a good perspective of what he's busy with. He gets a 3D view of where he is at, where services should be and shouldn't be. And it helps to make the design and what we are trying as consultants and as architects, trying to design and put into practice. So you can't expect someone to see what you are envisioning yourself. Because let's be honest, as an engineer, the whole design starts here. It starts in your mind, you visualize it, then we have to put it down on paper, and we have to put it down in a 3D world. And we exclude the contractor from the 3D world a lot of times. But with the digital twin, if we've got the mindset of the digital twin, it means that when we are modeling in our construction phase or in our design phase, we are making sure that the information we are putting in is 100% accurate. So when he takes that model, he will see, oh, this is where this is fitting, this is where that is. And he can have a look into what your design is supposed to be. Because a lot of times we have a design, and when we come to site, we realize that they've changed it. Why digital twins matter in the engineering workflow? Life cycle operational value. It reduces operational costs. How does it reduce operational costs? By implementing this, they can actually look at a live model of the building, seeing how everything operates. So if you have an HVAC unit that's not working optimally, you can see that, and the data will show you that this equipment is not working optimally. And what happens is, you can, before it breaks down, you can repair it, or before it breaks down, you can order parts for it. Improve maintenance. It helps you to improve your maintenance because now you know. When you're looking at this twin model, you can see what is in the model, what is required. You can see how many HVAC filters there are, and you can order them beforehand to make sure that they arrive on site when the installer is there, and he replaces and reinstalls them. It saves energy. If you look at the electrical and the mechanical, there's a lot of rooms that might not be used. If you have an occupancy sensor in that room, the data will bring back saying that this room in this time periods are not being used. Why run the office aircon and the office lighting for an hour when everyone's out for lunch? Why is the basement lighting and the basement extraction fans running 24/7 where there's no need for it? We can dim down the light fittings for security reasons, and we can switch off the ventilation, and when everyone's coming back to the office, sensors pick it up and we switch it on. When it comes to saving energy as well, you can monitor your water usage. You can easily see when there's a dispute between your reading and council's reading. So you don't go a year down the line and got an excessive account with council. Immediately in that first month, you've got the information, you can dispute it. Improve safety. This was a very interesting one for me. They did, I think it was in Belgium, they had where they put a sensor behind the fire extinguishers. So if anyone picked up that fire extinguisher, it will automatically let the building management system know that someone has removed a fire extinguisher, the time period that it was removed for, so they could account for all the fire extinguishers in the building. And that is part of their safety plan and their safety routine, to make sure that on a monthly basis that all the fire extinguishers are where they need to be, where they are supposed to be. And they could monitor that through one single system. Reduces downtime. I said it, you can order parts beforehand. Office chairs, you can see how many office chairs is in that building. You can see what make and model office chairs is in that building. You can look at anything that's got some digital information in it. Recognizing the impact on time, costs, and material efficient enabled by BIM. Time impact, real-time access to acquired building information, faster clash detection between services, reduces rework on site, improves project scheduling and sequencing, faster maintenance responses through live monitoring. It's all things that was spoken about today as well. We all can see the benefits of that. Cost and material efficiency impact, accurate quantities, take-off and costs. If we put the information in the model, we can pull schedules. We can see the information and we know exactly how much of what item should be in the building. We can put costs to it, and the schedule can show us the costs relating to that. Early detection of design conflicts before construction. Architects spoke about that as well, that we have that early detection because it's real data that we're putting into our models. Predict maintenance instead of reactive repairs. You can, each individual item can be shown the warranty of that item, when it needs to be maintained, when it needs to be replaced. And I'll show you at the end, Autodesk has got a beautiful piece of software that actually allows you to take all this information and integrate it into one. Better asset life cycle planning. So your Rivet model is not just being put on the shelf. It's actually being incorporated and given new life for the building management system to use it and to give us accurate data and information regarding it. Practice lessons and best practices from my perspective. Always when we are modeling and looking at modeling, and I think that's something that Bogertman has really done beautifully, is model with construction in mind. When we are modeling, we are not just modeling to get a design done. We are modeling with construction in mind. You see, and that's why I said that you have to have the right mindset. Because a lot of times we are pushed for time, we are pushed for deadlines. But if we have the mindset of this is going to be our digital twin, we need to make sure what we're putting in the beginning is correct. We can't come back a second time and redo it. Let's get it right from the beginning. And that's why I said that we need to look at the mindset. Coordination is more important than speed. She spoke about service zoning, setting out those zones to make sure. And this all helps with when we are making it a digital twin, because it gives us more time to focus on these things, because everything is already set out in service zones. Keep models clean and standardized. Use BIM as a data tool, not only a drawing tool. Important that the data that we put in there is accurate and correct. And I can see that the suppliers are going to play a big role in this as well. Because we're going to start pressurizing them to give us families, to give us models that are accurate. So that when we buy the equipment from them, when we get equipment from them, that it is an accurate replica of what is being installed on site. Reduce rework through early detection. Learn site conditions and installation methods. And the last one, adapt to technology. If we want to see our buildings have a longer lifespan, we need to adapt digital twins, so that building maintenance can become easier and more accessible to everyone, and so that the building can be taken care of and help with carbon emissions and all of those things as well.
Autodesk's ecosystem supports a seamless transition from design to operations. Project teams can embed structured asset data within the Revit model and synchronize that model across disciplines in the cloud. Once the design is finalized and models are published to Autodesk Docs, Autodesk Tandem consumes this data to create a data-rich, dynamic digital twin. For digital twin compliance, Revit supports the inclusion of the following structured asset metadata directly within model elements. COBie-compliant fields such as type name, serial number, warranty dates, and installation data. Custom parameters for asset classification, system hierarchy, and location tagging. Shared parameters to ensure consistency across multiple models and teams. This structured data becomes the foundation for future asset tracking and digital operations in the final approved model. Tandem ingests the model, maintaining all geometry, metadata, and relationships between systems to create a digital representation of each physical component. Asset types are then organized by building zone, system, or hierarchy to mirror the real-world environment. In Tandem, each asset can be enriched with OEM specifications including model numbers, part catalogues, and maintenance schedules, technical documents such as user manuals, as-built, certificates, commissioning data, and more, hyperlinks to warranty providers, installation videos, or support resources. For example, a facilities manager can select a digital boiler in Tandem and immediately access its manufacturer datasheet, installation date, maintenance log, and warranty documentation. Tandem also supports integration with IoT sensors and building systems, enabling real-time operational awareness. Asset and system performance data can be overlaid on the digital twin to support energy use tracking, temperature, humidity, or pressure readings, predictive maintenance based on runtime or performance thresholds, space utilization and occupancy trends. This transforms the digital twin from a static handover record into a live, data-driven operational model. Autodesk's workflow from Revit to Tandem enables a connected, intelligent asset lifecycle.
Very